I would like to show that the athletes and coaches can use the scaling system to track their progress relative to their performance of their age group and body mass. And I created a web application so I can use.
Hi, Marianne. It's my pleasure to have you on the Evidence Strong show for the second time. Please briefly introduce yourself.
Thank you, Alex. I'm delighted to be here and to speak to you. I am Marianne Huebner, and I'm a professor of statistics and probability at Michigan State University. I've been competing as a master's athlete in weightlifting for about 10 years. And I became interested in weightlifting research on topics where I thought there were gaps in the literature, and I had questions as an athlete. And that includes body weight, influence of body weight on weightlifting performance at different ages.
So we got in touch when you published your one of many previous papers on methods to compare weightlifting performance across weight class. In weight class, it's pretty easy. The rule is whoever wins the weight class, so lifts the highest total, wins the competition. But then we have lifters in the lower weight classes and in the higher weight classes, and we try to compare who is better. If we have to choose the best female athlete of the competition, who should win? And then we run into problems. How to fairly compare who is strongest when we have to take into account athletes from different weight classes. So you are on a journey to make this possible and to make it reasonably fair, and that's why we're here. So let's start with a brief history of the previous approaches to how to do it, and hopefully we will get to where we are now and the new exciting developments that you've been leading.
So scaling the weightlifting total to count for the body weight is not new. There are many approaches. We could take hours to speak about them. I'll just mention three, and that's the Sinclair formula. That's probably the longest standing one. The Robi points and the Q points. They've all been developed to compare performances in weightlifting, and many nations use these to determine best lifter, best male and best female lifters in the competitions, or possibly even for national team selections.
Yes.
I can show a picture to say something about why we do that. So here we see a picture of the total weight lifted across age, on the left-hand side for the women and on the right-hand side for men. And we can see that the males typically lift more weight than the women. And we also see that there's a change across years. So from youth to about mid-20s, there's an increase and then there's a decrease, both for men and for women. So that is one of the things that we'd like to address. So Q points, I've looked at this across body mass. And Sinclair points also. So if we adjust the weight lifted across body mass for the Sinclair points, we'll see in this picture, in the bottom picture, that there's an increase or higher Sinclair points for the higher body mass. And we also see that men get higher Sinclair points than women. So the approach of the Q points was to flatten the line to make it more comparable from the lightest weight to the heaviest weights. And that was successful with the Q points, both women and for the men. We still see the difference that men would get higher Q points than the women. Then we will work on getting towards the GAMx points. So here we see the picture that the higher body weight, the more weight is lifted. And if I use the methods of the GAMx points, I can also even this out, just like we were able to do with the Q points. But the advantage here is that both men and women are on the same scale. So both have the average of 1,000. And if I go briefly back to this one, so here the Q points were, a little over 300 for the women and a little above 400 for the men on average. So now with the GAMx points, we have it on the same average.
So does it mean that now with GAMx points, we can calculate GAMx points for female lifter and for male lifter, for example, for national team, and we will be able to say who did better?
Yeah, we can use this for mixed teams. So the idea here was that the strategic plan by the International Weightlifting Federation envisioned new formats for weightlifting competitions. And that included mixed teams consisting of both men and women. And since men typically lift more than women, we need a method to account for those sex differences in the ranking of the performances. This is also interesting for local or regional competition organizers who want a better way to award medals for really small groups. So that's the reason why I developed these GAMx points. There were these requests. First, I did it for seniors, and then I worked on the age adjustments for youth and for masters. And these GAMx points can be used from ages 7 to 90 years old. So mixed teams are now possible. The GAMx points are a way to compare the performances across body weight and sex. And we can do this in those different age groups. To say a little bit more, I just named GAMx point after the statistical method. Nothing fancy. It's generalized additive models adjusted for sex. So all these letters are in these names. And as you saw, the median, the average GAMx points is 1,000 in those scales. And the reason for that is that we don't confuse it with the total kilograms lifted, because that's an issue with both Sinclair points and Q points. So I wanted to do this specifically, have it at that ranking.
How did you develop GAMx point?
Okay, actually, it goes to the question that you asked earlier. What can we compare with the GAMx points? So you need to think about that we're all comparing an individual's performance to athletes of similar body weight, age, and sex. So separately for the men and separately for the women. And to be able to do that, to get this on the same scale, I replaced everybody's total by a standardized score, or called the Z-score. And those are obtained from the model. I'll show a quick calculation as an example. Here's an example. We have a male athlete who's 40 years old, a body mass 93 kilos, and he lifts 258 kilos total. The statistical model has 3 parameters. I'll call this location, variation, and scale. And we would look up the age and the body mass and the sex to find these 3 parameters. And it's a lookup table that I have published, so it's open access. We will use this to calculate the standardized score, called the Z-score. And I have all these numbers, the 258 kilos total, this standardized parameter to reference it, scaled, and I will get a Z-score of 0.21 using this formula. The GAMx score, and this is now for masters because 40 years old, is then 100 times this scaled number plus 1,000. So this male athlete lifting 258 kilos would get 1,021 GAMx points. So it's above the average of the GAMx. And I created tables like this for different groups. Here's an overview table, how I developed them. So we have the GAMx for masters, GAMx age adjusted, and then GAMx for the kids or under 17. So for the seniors, like 15 to 40-year-olds, I used the IWF Senior World Championships and Olympics from 2019 to 2025. And the body weights in there was 40 to 190 kilos. And the models adjust for the body weight and for sex. So we can use it for the seniors, but you can actually also use it for the juniors. This gives the parameters when it's possible. Then I wanted to expand this to the masters. So I needed an age adjustment also. So in addition to the body weight and sex, I used an age adjustment. And this was based on the IMWA Masters World Championship from 2018 to 2025. The same range of body weights. And it's been created for ages 30 to 95 years. I expanded the ages a little bit, so predictions that is possible. But then I thought about, well, how do I get this for the youth? We have it for the senior. How do I get this for the youth? So I used all the IWF World Championship for youth, juniors, and seniors, just like the seniors above for the same years, and adjusted for age, body weight, and sex. So this is now possible for ages 13 to 40 years old, and it starts at 30 kilos body weight. Lastly, we know in USA weightlifting, there are 7-year-olds and 8-year-olds. So I still USA weightlifting national championships to see whether I could come up with something for the youngest group. That it would be the minimum of 25 kilos. So that's the one that's the national championships, because I didn't have such data from any other country. But now if I think about it, can we really compare the GAMx for masters with the GAMx for seniors? Because, well, 40 years is possible in both, but we really can't, because the GAMx masters are based, the reference are all the Masters World Championships, while the GAMx for the seniors, the reference of the Senior World Championships or Olympics. So it's a much tougher comparison. That means probably a 40-year-old GAMx versus 40-year-old GAMx master. The GAMx master would have likely higher points. Across these different age groups, it's not necessarily good. One thing that can be done across age groups is GAMx A. I provided this in case someone wanted to use it. So to show this is the GAMx A, the age adjustment. Originally, I only wanted it for youth, but it works for youth, junior and seniors. And we can see how it works. So across the body mass, we can see this. 1,000 is the average, and across the age 1,000 is the average. So I was very excited about this result.
Sorry, so age-adjusted GAMx, so GAMx A, could be used from
13 to 40 years old.
13 to 40 years old. So if you have youth lifters at 13, starting 13, and masters lifters up to 40 in the same competition, you could possibly use this to determine who was the best lifter.
Right, yeah, because all of these data were included in this one. I could also talk about, is the GAMx points really better than the Q points? Because we saw in earlier pictures, both of them were level, and I know some nations already use the Q points.
Mm-hmm.
So let's look at actually particularly the Q points for the masters. Okay, so here we have the Q points for the masters, or it's called Q masters, and we have it across age, and I show it across body mass. So looking at the across body mass, I struggled a lot when I developed the Q points for the women, because I could not get this in a straight line. That's the goal. They have it the same scale across body mass, but what the Q points do is they preferentially treat the lighter weight women, and the heavier weight women will get less points. It's more prominent in the women than it is for the men. That's across the body mass. Now, the Q points were developed for the seniors. And then we just try to fix it with an age factor so that it would be applicable for masters also. And I developed the age factors for the masters, and it worked relatively good. But the age factors for the men look like they are preferentially treating the oldest men here. Let's see what the GAMx does. I was able to adjust this one because the model for GAMx includes the variation that the Q points don't. And here's the result for the GAMx for masters. Across the body mass, it's very even, and across age it is also. So it fixed the problem for the Q points for masters.
What are the negatives, if there are any, for GAMx points?
So that's what I mentioned, actually, that it should still stay within the age groups. I tried across the age groups, but I got results that makes no sense at all. It is just too large of a range. But each one of those has relatively good ranges. And the reason why it doesn't really work is the reference values. The reference values are just different populations. The seniors are a different group than the masters. So even the Olympians that continue into the masters age group, they may not train as a high level as they did for the Olympics. So it's a different group. I could show, well, what has always been interesting is, how often does it need to be updated, this model? And I've been really, really excited about what that is so steady. This picture is for the masters. I have a similar a picture for seniors in a paper, but I wanted to look at it in a master's in particular because there has been some change over time. So what we see here is that, well, it's hard to see, but before 2013 or so, the points, the GAMx points for the men were about like 30 points higher than the 1,000 average. But since then, it's been 1,000 just across the time. For the women, it's a little different. So before 2015, it was like 100 points lower, but you can see it has improved, and now it's steady over time, and we have this gap of the pandemic years. We can also see, I just wanted to point out that the standard deviation, so this difference here, the black dots at the top, the black dots at the bottom, is narrower than it was earlier. So the standard deviation has decreased, the variation has decreased, and the same for men. So it has become more stabilized. So it's interesting to see, well, why is it the case that we see this increase in the women's performance over time? And it goes hand in hand with the participation. This is the participation in the World Masters Championships. So we've seen an increase over time in the men, but we've seen a dramatic increase over time in the women. So there were up to 2012, there were fewer than 60 women per year. And then it rose up to 300 to 350 after 2020. So in 2010, it was only 14% of the participants were women. And in 2025, that has risen to 51% are women.
Wow.
So this increase goes along with actually the improved performance that we're seeing here. Yeah.
So do you think going forward, GAMx will hold?
Yeah, I don't think we need to change it often, but I would look at the masters. There's still some shifts, in particular in the oldest women range. There are older women grow into that, and so we hopefully will see more participation across all ages. And then we can check what, like every 5 years to see what is the case for the masters. But I think the others are pretty stable.
Awesome, that looks exciting. We just gain new possibilities in comparing the totals. So that's great. We can now compare between females and males. So we can have mixed teams. We can have fair comparisons with selection or with assessing the performance and so on. We talked about the overtime. Any summary messages for coaches and athletes and organizations?
Yeah, absolutely. I would like to show that the athletes and coaches can use the scaling system to track their progress relative to their performance of their age group and body mass. And I created a web application so I will show that, demonstrate that just really quickly. This is the web applications, but there are also Excel spreadsheets that are available for download. So here I have the total for the GAMx points, the GAMx for the masters, and I write down 30 years and older. This is for the GAMx A, the age adjustment, youth, juniors, seniors from 30 plus kilos. And this is the GAMx U for under 17. I can select here what I would like, the masters or youth. Let's stay with the senior for a moment. Let's say a male. I can choose the body weight, say 74.5 kilos body weight and lifting 230 kilos. Oh, well, how about a little more? About 300. And this is the GAMx points 915. I can also add, well, let's say my goal is 1,000 GAMx points. How much do I need to lift in the total? And that shows right here. That would be 325 kilos. And I have the same thing for the masters. So let's say the masters, let's do females, also 75 kilos. Well, masters, it says check the age. That's not masters yet, but let's say 35-year-olds and lifting, say 200 kilos. That's a really, really good number. far above 1,210 GAMx points. If I say I would like to get 1,000 as a GAMx points, the lift has to be 156 for the total. And the same one can be done all the way through the GAMx A and the GAMx U points. Below here, I just wrote it all up. What are all these differences? And I'm just saying this is how it's derived from a z-score, and I also have the references where it comes from. Both papers have been published for the masters and for the seniors. Now there's something interesting that I worked on that was suggested to me as to what are the GAMx points for the snatch only, or the GAMx points for the clean and jerk only. So that enables actually mixed teams where an athlete only does the snatch and another athlete of the same team only does the clean and jerk. So that is a possibility if we use this one. So I did this for the seniors and for the masters. So these two choices, seniors and masters. And so let's say we have a senior male, 60 body weight and 100 kilo snatch and 130 kilo clean and jerk with age 25. Well, for seniors, the age doesn't matter. We get the GAMx points for snatch and we get the GAMx points for clean and jerk. I called it GAMx S and GAMx J. And also, again, I can put in the goal to see how much should be the snatch, how much should be the clean and jerk, and calculated the ratio here of ratio of the snatch to the clean and jerk to see whether it is close. And we can do the same thing for the masters.
So the ratio is from GAMx points?
GAMx points.
Yes.
Right.
Okay.
So lots of possibilities. I was quite interested to see that, just checking my own actually to see whether I'm better snatcher or clean and jerk. My snatch GAMx points were higher, and I can check it actually also for the Olympians to see how they developed also over time, which is really interesting to see, to keep track of your own. So that should be really helpful, I hope, for athletes and coaches as well as competition organizers, because they have then a lot more possibilities. I didn't do the GAMx snatch and GAMx clean and jerk for the youth or the age adjusted because I don't know whether it will be used, but it can be done.
I wonder also how stable it is with use as they develop. Everything changes, the age changes, the body weight changes, the technique changes still. So the calendar changes, and I don't know, lots of variables.
It depends on what people would like to see. So we can do it for the total, so we can do it for the snatch and the clean and jerk also.
That's awesome. So we have option to compare between weight classes. We have option to compare between weight classes and sexes. And we can separately compare total, snatch, and clean and jerk between athletes of different body weights and different sexes.
And I actually specifically make the average 1,000 for everything.
This is awesome. This is game changing. So IWF already announced that they will be using GAMx points from now on in international competitions.
GAMx points and Robi points, they still keep the Robi points too. And they did not say how they were going to use it. They just said they support those 2-point systems. That we will see how it develops over time.
Yeah, Robi points were pretty rough on athletes. They are hard to understand. A lot of comparing to the benchmark, but not in a...
The difficulty with the Robi points is the benchmark, as you say, is the world records.
Yeah.
So here, the advantage of the GAMx points or Q points also is that it uses all the data, not just the world records.
Right. Okay, so fingers crossed it will be implemented in a reasonable and transparent way, so we know what we are standing in, because it will influence how the teams are approaching competitions. And if the competitions with mixed teams develop, or separate competitions for snatch or separate medals for snatch and clean and jerk will be proposed, that will also influence how the athletes and the teams prepare for the competitions.
So far it's been possible to rank, give overall best awards for the total, but now it's also possible to give overall best awards for the snatch and overall best awards for the clean and jerk.
Looking forward to it. Would be an exciting format to acknowledge the athletes who are great specialists, but maybe not up there with the total. So that could be interesting.
Yeah, I look forward to it.
2 last questions I finish with. The first one is, what is your favorite lift?
I like both snatch and clean and jerk. I really like in the training lifting from blocks.
Why is that?
I just enjoy lifting from blocks. Just, partial movements, trains different things.
Right. And where people can find you?
There are lots of places. I showed the web applications. You can also put a link to the Excel workbooks for these, because that has the lookup tables for all those parameters that I showed
awesome.
earlier in the calculation. And I have quite a collection of weightlifting research papers. They are on the IMWA, International Masters Weightlifting Association website. They have a research website. And otherwise, most of my publications are on Google Scholar.
Excellent, Marianne. Thank you very much for today and for all your hard work to get the sport to be better.
Thank you. I'm excited about this work. So I would like to also acknowledge my collaborators. Tim Cole from the UK has made the original suggestion to go to the generalized additive models. And my colleague Ray Lay from Michigan State University helped with the age adjustment that I had a technical difficulty with.
Excellent. Thank you so much.
Thank you.